Hello everyone, I am K. Teja, a third year student from CMR Engineering College. I did my internship at emetrex and built something like a mini EV dashboard, the kind you would see in a real electric car using a small microcontroller called STM32. It also has a basic safety system like the collision warning you see in the modern cars. Let me walk you through what I built, and then I will show a live demo as well. So basically I have made a small computer chip which acts like the brain of the electric car. It tracks things like speed, battery and temperature, and it also has three distant sensors like ones in the car that beeps when you are too close to something. This whole thing runs on one small board, not real car needed here. Everything is simulated, so the tools and development environment that I have used in these projects are STM32CUBE IDE. This is the place where I wrote the code. It pretends to be the actual hardware, so I did not need any real bytes or sensors here. So Python is used to create nice dashboard screen to show speed, battery and all of that visually. VSP and Terata. This is just a simple window where I can type command and see message from the chip. So coming to the system architecture, this is the flow of our project. Starting from sensors, it reads the distance and pedal position. EV control, it is the car brain which indicates the speed, batteries. It checks for danger like something too close in front. Fault, it checks if something is going wrong like overheating. It sends everything to my computer screen. They all check with each other 10 to 100 times every second. So every updates here almost instantly. So coming to the pin configuration, so we are using potentiometer here. So the pin range for it ranges from PA0 to PA3. So PA0 indicates the accelerated pedal, PA1 indicates the brake pedal, PA2 indicates the state of charge, and PA3 indicates the motor temperature. For the digital input output, we are using three ultrasonic sensors here. So for the front ultrasonic sensor, PBO and PB1 pins are used. 0 is for the trigger pin and 1 is for the echo pin. Similarly, for the left and right ultrasonic sensor, PB2 and 3 are used. For the right, PB4 and 5 are used. So we are also using 4 LEDs here. PB8 LEDs for the collision warning, PB9 LEDs for the blind spot left, PB10 LEDs for the blind spot right, and PB11 LED is for the LED which indicates the fault active. And these are the formula which are used for the conversion here. So how the distance sensor work here, which is ultrasonic sensor. So the ultrasonic sensor sends out a short sound pulse like a mini shout and waits for the echo to bounce back. The longer it takes to come back, the farther the object is. So the formula is time taken into speed of sound divided by 2. We divide by 2 because the sound travels to the object and back. We only want the one-way distance here. The sensor can measure between 2 centimeters to 400 centimeters. If nothing is nearby, it just shows 400, meaning nothing is being detected. So coming to the timers, we are using 3 timers here. One is to update the car speed and battery, 10 millisecond basically instantly. Another checks for the distance and danger warning every 100 milliseconds, 10 times a second. And third one is just to use it to measure how long the sound echo takes, like the stopwatch. and how the car speeds up and slow down. When you press the accelerator, torque, which is like the push force, increases. There are three driving modes: eco, normal, sport. So in the eco mode is a gentle mode. About 60% of the power is being used here. Normal uses regular power and sport mode is stronger. About 130% of power is used here. And we also have 5 states here: park, ready, driving, regeneration and fault. So the car goes from parked state to ready state when the acceleration pedal is being pressed, and from ready to driving it goes to automatically, and from driving to regeneration it goes when the brake pedal is being pressed above the threshold, and fault state goes whenever any kind of fault is detected in the above mentioned states. So when you press the brake, if it does not just stop the car, it also puts a light energy back in the battery. That's called the regenerative braking. Same ideas as the real electric cars. So battery and the range, the battery percentage drop based on how much power the motor is using. If the car is not moving but the motor is working hard, the battery still drains a little, just like in the real life. Running the AC is the parked car still uses battery, right? Similarly here it also uses battery. Range, how many more kilometers you can go, was calculated from how much battery is left divided by how much energy the car uses per kilometer. Eco mode uses less energy, so range is longer in eco mode. Coming to the ADAS part, so this is the safety part. Two things are checked here: how close the object is in front, and how fast are we going, and how soon would we hit it. The second one is called TTC, which is time to collision. It means how many seconds until we crash if nothing changes. The formula for TTC is distance divided by speed. If the object is very close or a TTC is very short, we get a warning. If it's even closer or more urgent, we get a critical alert. Roughly under 50 centimeters or 3 seconds, warning has been generated. Under 20 centimeter or 1.5 second, critical is being generated. And coming to the blind spot and another checks, there are also called blind spot detection. If something is within 30 centimeters on the left or right, and we are driving faster than the 20 kilometers per hour, it warns us. It only checks this while actually in the driving state, not while in the parking or just like the real car here. There is also a overspeed check. If we go above 120 km per hour, it gives a gentle warning. So coming to the fault detection, and this part watches for problems such as motor getting too heat, battery getting too low, and a serious crash warnings. If anything happens, the system automatically stops the motor for safety. It does not wait for any